Okay, day 2, section 4.3. All right, yesterday we ended using special right triangles to evaluate trig functions. We're going to still do a little bit more with that. We didn't quite wrap that up. Today we're also going to work on solving trig equations in the open interval 0 to 90. It actually is still related to special right triangles, so these go hand in hand. And we'll kick off some of these real-world problems today. We'll also probably need tomorrow because these take some time to set up. Okay. All right, so here we go. This is where we left off on example 7 yesterday. Okay. All right, so 8, 9, and 10, we're still using these special right triangles because these are still some of these common angles, just, I guess, disguised as radians. All right, so pi over 6, in a problem like this, if you weren't quite sure what pi over 6 is, then you could kind of go off to the side and use your prior skills to take pi over 6 and convert it to degrees, if that will help you. So I'd want to put the pi in the bottom of this conversion factor, so that's gone, and then do the math. So I've got 180 on top, divided by 6, which is 30 degrees. That's a common angle. The quicker you get that memorized, the better. Okay, it might even be good to write that up here in this box. Pi over 6 is the same as 30 degrees. Okay, pi over 3 in radians is equal to 60 in degrees. Okay, a good way to quickly figure that out, by the way, remember what pi is. Pi is a straight angle. It's 180 degrees. So a quick substitution to figure that out is 180 degrees divided by 6. 3. I'm sorry, 18 divided by 6 is 3, right? Add the 0. Same thing here, right? Pi is 180, so if I do 180 divided by 3, I get 60 degrees just like that, okay? So use that trick if you want, but these are equal. Okay, so number 8 calls for the cosine of pi over 6. So where's pi over 6? It's right here. It's the smaller angle. So now that I know that and I have the location of this, then this is the adjacent side and this is the hypotenuse. All right, so the answer to that is going to be square root of 3 over 2. And that's it. Don't need to rationalize that or anything. That's the answer. Okay, so 9 and 10 also are relating common angles to these triangles. Okay, so I'm going to give you a chance to try these on your own. Yeah, they are reciprocals, but one little push in the right direction. If they have cosecant, maybe you want to start by writing down on paper what the sine is. Remember, sine of theta is opposite over hypotenuse. So that means cosecant theta is going to be h over o. Okay, naturally because of the reciprocal relationship. Okay, your turn. Try 9 and 10 using the triangles above, and I'll give you some feedback on that. All right, so cosecants. The hypotenuse for the 45, 45, 90 triangle, because pi over 4 is another angle we might want to add up here. That helps you. But if you use that trick that I gave you, right, pi is 180, so 180 divided by 4 is 45 degrees, okay? And you get it. All right, so yes, we get square root of 2 over 1 by looking at that triangle, or just square root of 2. 10, cotangent. Since tangent is opposite over adjacent, then this has to be the reciprocal, adjacent over opposite. So find pi over 3. Pi over 3 is this angle here. So the adjacent side to this angle is here, 1 over the opposite, square root of 3. So we're going to do 1 over the square root of 3. Don't leave it in that form, okay? Rationalize this. Always leave your answers in radical form, too. A few of you on your quiz punch this in your calculator. We want exact form, not approximate forms. Those decimal approximations of these radicals are approximate. Keep it in radical or exact form, okay? All right, so for this next set of problems, it says find each value of theta. So now we're given the right side, we're looking for theta in degrees, and they want us to also give it in radians, okay, from 0 to pi over 2. Pi over 2 is obviously 90 degrees without using a calculator. Okay, so you might want to make note of this. Why don't you write this down underneath just to guide you. we're going to use the special right triangle still above, okay? So use the special right triangles and trial and error. Use the special right triangles, and then we'll just kind of use trial and error. Okay, so it's not a lot of work to show for these. If any work you would show on maybe your OTI or your quiz is maybe the special right triangle you're using. They're right above. I don't need to write it down. Okay, I just wrote down what I did. So which angle, keeping in mind that cosine is defined as the adjacent side over the hypotenuse. So right now I'm looking for the angle that has an adjacent side of 1 and a hypotenuse of 2. Okay, so maybe you thought, all right, it's the 45-degree relationship. So grab one of these and check it. Adjacent, 1 over square root of 2. That's not the same as 1/2. So that didn't work. So which one's going to work? What about 30 degrees? Well, adjacent would be square root of 3 over 2. 60 is going to work because the adjacent side now is 1, hypotenuse is 2. Okay, so the answer to this, theta, is 60 degrees to get a cosine value of 1/2. That's it. That's what we're looking for this. Okay, so theta is 60 degrees or pi over 3 in radians. Okay, just like that. All right, let me show you 12 and then see if you can figure out 13 and 14. This one's a little bit tricky because it's already rationalized. But the good news is there's only 3 choices up here anyways, right? It's only 3 angles. So that's why trial and error is just something that you got to try. All right, so I wouldn't want to trial and error with 45 degrees. Why? Because this has a square root of 3 in it. I'm not going to get a square root of 3 from this. So I'm not going to waste my time here, but if you did, and if you tried it, it just wouldn't work out. Okay, so remember, secant is defined as the reciprocal of cosine. So secant theta is hypotenuse over adjacent when I start testing these. Okay, so just try some trial and error. So for example, let's just say we think 30 degrees might be the answer. Okay, so if it was 30 degrees, secant would be the hypotenuse is 2 over the adjacent side square root of 3. And then let's just try it out. Okay, so I'm just going to hypothetically move forward with secant at 30 degrees. What does that give me? Trial and error. So those sides I just looked at were 2 over the square root of 3. And then rationalize it. What does that give us? Square root of 3 over square root of 3 and multiply. So up top, I get 2 square root of 3. On the bottom, we get square root of 9 or 3. That's what we're looking for, right? That's the answer. So I just verified what the answer is. If you randomly chose 60 degrees, that's fine. You're not doing anything wrong. You're doing the trial and error. But if we did secant for 60, it would have been 2 over 1. And it just wouldn't have worked, right? Would have got 2. That's not what I'm looking for. Okay, so when it's rationalized, you got to realize that this isn't really technically the hypotenuse. It's not really technically the adjacent side. It's because it's already been rationalized, okay? So the answer is, we just verified, theta is 30 degrees or pi over 6. All right, your turn. It's going to be one of the 3 angles, 45, 30, or 60. Figure out which one works for 13 and 14. Okay. Okay, 9 is 45 degrees or pi over 4. Oops. And we can verify that by looking at it. 1 over 1. Okay, so 45 degrees or pi over 4. And 14 was the same angle. And here's the justification I did. Sine of 45 up there. Choose one of the 45-degree angles. We get 1 over square root of 2. Rationalizes to this. So same angle. Okay. Okay, let's take a look at some of the applications on the next slide and these new phrases. Angle of elevation, angle of depression. Angle of elevation, here it is over in this diagram. It always starts from a horizontal line. That's what's important here for you to understand for angle of elevation. And it's the angle going from the horizon up to some objects. Okay, so the words say this: represents the angle from the horizontal upward to an object. Angle of depression also starts from the horizontal. My difference now is that it's going downward to an object. It seems like a very easy concept. However, time and time again, students place angle of depression in the wrong spot. So you got to remember both of them have to start from the horizon when you create your sketches. Angle of depression starting here, now rotating down. So problem like 15, I know we didn't read it yet, but for example, this says angle of depression is 31 degrees. Many students will draw a triangle. You don't have to draw this in here, I'm just showing you. And they'll put 31 degrees here, but it's not. These are complementary angles. They add up to 90. I would not put angle of depression here. There's no horizontal line, okay? But students do it, okay? Don't be that student. Make sure you form it from the horizontal. Okay, so let's go ahead and take a look at 15. Brian's eye level is 1.6 meters above the ground. He is standing on a cliff, which is 30 meters above sea level. Measures the angle of depression is 31 degrees. There's these little like binocular looking things that can measure angle of depression, angle of elevation. Calculate Brian's horizontal distance to the boat. So this is the unknown right here. We'll call this X. Okay. All right, now we do know this because angle of depression is measured from the horizontal. So if I transfer this across, we've got 30 plus the 1.6 meters. So this side length is 31.6 meters. Okay, so in finding unknowns of a triangle right here, when we're going to use trig, here's the key question you want to ask yourself. How are the sides related to the angle? Okay, so for this 31 degrees, here's our triangle we're using here. How are these related? Well, this is opposite, right? This is the opposite side, and this is the adjacent side. So that determines which trig function we should use. Some students get confused on these, like, why did you choose tangent? Well, because tangent's the only trig function that deals with opposite and adjacent, and cotangent, but we usually like to stick with the first three. Hypotenuse is not in the equation here, right? It's not given. All right, so we're going to set up a trig ratio now. Tangent of an angle, in this case we have the angle, so tangent of 31 degrees is equal to the opposite side, 31.6, over the adjacent side, x. Okay? And as long as I have two out of these three of this ratio, we can solve for this. Our calculators are programmed to know what tangent 31 degrees is. So how would we solve this for x? Here's what I recommend doing before we pick up our calculator. Just cross multiply to get this out of fraction form. So I'm going to put this over 1, and let's cross multiply. So what is that going to look like? Remember, you just multiply numerator times denominator and vice versa and set them equal to each other. So I have x times tan 31 equals 1 times 31.6, or just 31.6. Okay, I'm almost solved for x. Since x is being multiplied by, this is just a decimal in our calculator, I'm going to divide by tan 31 to get it by itself. And this is what I'm going to punch in the calculator. Okay. Make sure you're in degrees. This is not 31 radians, it's in 31 degrees. So if you go to mode, make sure you select degrees. Okay. Okay, now it's ready. We're just going to do 31.6 divided by the tangent of 31 degrees, and we get our answer. 52 points, whatever they asked us to round it to, 59 meters.